Okay, this is another video. Of course, this one is specifically for those persons that are writing post-UTME exam in uniben. Of course, you can also watch this video if you are writing any entrance examination at all that concerns chemistry. So quickly, this video today might be longer than usual, but I'll make it also brief as I usually do. I like my things very, very short. Now, look at it. I have a few questions I want to review today. And if you have been following the lecture series, of course, if you have not been following, it's your first time of watching the video with MOSJARO, all you have to do is to, of course, subscribe and do well to always share after you watch so that others can get to watch, see the video, and of course, learn chemistry in a very simplified way. Now, look at what we are doing. We're trying to analyze questions and not just looking at the questions. We are looking at how the answers is like that and why the answer is like that. And those options that are wrong, we're trying to analyze them also so that next time when we see them in our examination we'll to trash them out. So quickly, let's jump into the question as usual. Now, there's a question here that says, it said, which of the following is not a giant molecule? A, protein. B, sucrose. C, starch. D, enzymes. Now, they say which of the following is not a giant molecule? Now, you might have already known the answer. The answer is quite easy, but you ask yourself, why is the answer like that? First of all, giant molecules, of course, are macromolecules. They are large molecules. They're regarded as what? As giant molecules. And giant molecules usually exist as what? As polymers. Though not all giant molecules are what? Are polymers, but all polymers are giant molecules. So going back to the option, you will be able to trash the answer by looking at which one of them is a polymer. So if it's a polymer, definitely it's a what? It's a giant molecule. Now look at option A. Option A here is what? Is protein. Now protein is a giant molecule. It's a polymer, definitely, and of course, it's a giant molecule. Now, it's a polymer that is made of monomers. And what are the monomers of what? Of protein is amino acid. Now, talking about option B, which is sucrose. Now, sucrose is not a giant molecule. The reason being that sucrose is made of two monosaccharides. Now, what are the monosaccharides that forms what? Sucrose. The monosaccharide that forms sucrose is what? Glucose, and of course, and fructose. So because of it's made of two monosaccharide, this sucrose is a disaccharide, so it's not a giant molecule, neither is it a what? A polymer. So the answer obviously is what? Is B. But be very careful about sucrose. You know that sucrose is our common table sugar, and of course this sucrose, if it's hydrolyzed by dilute HCl, is going to form glucose and fructose, like we earlier said. If sucrose is treated with concentrated H2SO4, of course, it's going to give us a sugar charcoal. That process is what? Showering of sugar, which is a dehydration process. So they can get to ask us, when sucrose react with concentrated H2SO4, what will it give us? Of course, it will give us sugar charcoal, and that process is what? Is showering, and it's a dehydration kind of reaction. That means water molecule was removed. Now, quickly, look at option C, which is what? Starch. Now, starch is a polysaccharide and it's made of repeating units of monosaccharide, many units of monosaccharide. So starch is a what? Is a polymer. Now, therefore, starch is a giant molecule. Enzymes are proteins, and because proteins are giant molecules, definitely automatically enzymes are also what? Giant molecules. Now listen to the analysis. I said that enzymes are proteinous, and because proteins are giant molecules, therefore enzymes are also what? Giant molecules. So what's our answer there? Obviously the answer there is what? Is B. They said which of the following is not a giant molecule? Sucrose is not a giant molecule. It's a disaccharide that is made of what? Two monosaccharides, which are the what? Glucose and the what? The fructose. Now remember, quickly, let me drop this in here, that sucrose is a non-reducing sugar. Now, all monosaccharides and disaccharides are reducing sugar, except what? One exception, except what? Sucrose. Now, quickly, look at question number 2. They said the process of heating slaked lime. I need to underline this slaked lime for those, of course, that don't know what slaked lime is. I like to take it from the scratch. So even if you are a novice in chemistry, you get to know some points, some areas too. Here they said the process of heating slaked lime with 10% sodium carbonate is known as dash. Now, someone actually sent me this question for analysis, and I've given the person the answer though. But I want to analyze each of the options so that you get to understand why the answer is that way. Now, quickly, let's look at it very quickly. They said the process of heating slaked lime. Now, you begin to ask yourself, first off, what is slaked lime. Now we need to analyze. Now slaked lime is what? Is calcium hydroxide. That is slaked lime. Slaked lime is calcium hydroxide. Now this slaked lime, of course, it can also be referred to as lime water, but if it's more dilute, it's called what? Lime water. Now let's leave that for now. Now this is calcium hydroxide, which is slaked lime. They are saying that the process of heating slaked lime with 10% sodium carbonate is known as dash. First off, if slaked lime is heated with sodium carbonate, is going to give me what? Sodium hydroxide as one of the major products. Now this is one method of producing sodium hydroxide, and this process is what is called the Gossage process. So the process of heating slaked lime with sodium carbonate is known as what? Gossage process. Now this process, remember what we said just now, this process forms what? Sodium hydroxide as the major product. Now look at it now. So we've understood the answer, why the answer is that way. So Gossage process is involved in the production of sodium hydroxide, when slaked lime is what? Is reacted or heated with sodium what? Carbonate. Now there's this other question I want us to look at again. Now we have seen our answer already, but let's look at the other options like we usually do. Let's drop out some bring out some gray areas. Now flash process, obviously when you hear flash process, what comes into your mind is in the extraction of what? Of sulfur. Flash process is involved in the extraction of sulfur. Now what about Sabatier process? Now this Sabatier process actually involve the reaction between carbon 4 oxide, I need to write it out, plus hydrogen gas to form what? To form methane, which is CH4, and of course H2O. Now remember what I said just now. What is this Sabatier process? I said the Sabatier process involves the reaction between carbon 4 oxide and hydrogen gas to form what? Methane, and of course water. Now of course we can get to balance the equation 4 and of course 2. If you check it, the equation is quite balanced. This is 8, this is 4, this is 8. Okay, 2 here. Okay, so this process here that I brought up now is this option C, which is what? Which is the Sabatier process. So when you hear the Sabatier process as a chemistry student, from today onwards, you simply know that the Sabatier process is involved in the what? In the manufacture of methane and water. But please take note that the reaction actually involves carbon 4 oxide and hydrogen gas. Now this reaction is involved in the production of propellants in for rockets in mass. Now reaction between carbon 4 oxide and hydrogen gas will form what? Methane and water. Now this process I said is called the Sabatier process. Now what about the Rosemont process? The Rosemont process actually involves the reduction of carbonyl compounds to produce what? To produce alkanes. Now let me give you an instance. Now we have okay, the reduction of not just carbonyl compounds. Let me give you an instance. We have we have ROCOCl. If I decide to do what? If I decide to reduce this compound, what will I get? I will have what? ROCHO. Now I'm removing chlorine, and of course I'm adding what? Hydrogen. So this is an acyl compound. This is an acyl, let me be specific, acyl chloride, while this one of course is an alkanal. Now what makes this reaction to be called Rosemont? Because a catalyst is used, and what's the catalyst used in Rosemont? Is what? PB in barium sulfates, which is poisoned with sulfur in order to control the reduction. Because if it's not controlled, definitely I can go and get what? Get a primary alcohol, so to say. Now look at what we decided to do here. Now look at the question. It said the process of heating slaked lime with sodium carbonate. We've answered that. That process is called Gossage process, and sodium hydroxide is produced. Now we said that flash process is involved in the extraction of sulfur, definitely. What about the Sabatier process? The Sabatier process is involved in the production of what? Methane, and reaction between carbon 4 oxide and hydrogen gas to form methane and water. Now what about the Rosemont process? I said it's a reduction kind of reaction where acyl chloride or acyl compound is being reduced. Controlled reduction. Why did I say controlled reduction? The reduction actually stops at alkanal. It doesn't proceed to primary alcohol. Now I'm going to break this down. first of all, but it's controlled because it's been poisoned with what? With sulfur. Now, quickly, why did I say control? Because you all know that first off, if this is ROCOOH, this is carboxylic acid. Now, this might not be concerned with Rosenmond, but I just want to bring a general understanding of things. Now, this is carboxylic acid. It can be reduced to what? To alkanal, which this alkanal can also be reduced to primary alcohol. That is to say, we have understood now that if I revert the reaction from primary alcohol, I can oxidize primary alcohol to form alkanal. Then, of course, I can oxidize alkanal to form what? Carboxylic acid. So that's why I said from here down, I can also get a primary alcohol, but I said it's a controlled kind of reduction. That's why the catalysts involved, the reagents involved, especially the lead, is being poisoned with sulfur so that it can be what? It can be controlled. So this is Rosenmond reagents, so to say. So we see how we analyze those two questions, bringing out some point. But I still have a lot of questions to drop. Like I said just now, the video might be longer than usual, but it's for those persons that are preparing for post-UTME exam. Of course, you can also get to watch the video regardless of the exam they are preparing for, to have a good knowledge of what? Of chemistry. So I have some other questions, of course, to revise with us as the video comes. All right, look at another video. Look at another question rather on a. This question is actually coming from salts solubility of salt. So we have to take it slow and steady. Now look at the question. They said, which of the following salts does not dissolve readily in cold water? Aha. Remember, they didn't say which of the following salt do not dissolve. They said which of the following salt do not dissolve readily in cold water. Now the option says A, calcium chloride. They said lead sulfate. They said ammonium sulfate, and they said sodium carbonate. Now quickly, I need to bring out the rules for salt solubility as regarding these options. First off, all chlorides are soluble in water. All chlorides, like all chlorides, that means any salts that have chlorine, they are soluble in water. We have exception. Now, I'm talking in respect to option A. All chlorides are soluble in water, except, what are the exceptions? Except those of what? Except those of copper, except those of silver, except those of mercury, except those of gold, and except those of lead. Now, as you are looking at the options, as you're looking at the exceptions, that means copper chlorides. But remember that there are two chlorides formed by copper. What are the two chlorides? We have copper 1 chloride, we have the copper 1 chloride, and of course we have the what? The copper 2 chlorides. Now, there are two chlorides that can be formed by copper. So definitely we have what? CuCl, and we have what? CuCl2. Now, though we have stated that all chlorides are soluble in water, except, that means these are the exceptions. That means these ones ought to be insoluble in water. But we have to be very careful that copper forms two chloride. You see, that is where chemistry becomes very, very beautiful and still tricky at the same time. So you don't just cram it, you have to be very careful. So as you're preparing for an entrance exam, you have to be technical. Now, even though these exact questions will not come out in the exam, but you use it to practice and know how questions are being set. Now, this is the third question that we're analyzing for this particular video, but you have to be careful still. Copper 1 chloride is insoluble, but copper 2 chloride is soluble. So since copper forms 2 chloride, amongst these 2 chloride, one of them is still insoluble. Bad guy. Copper 1 chloride is insoluble, but copper 2 chloride is what? Is soluble. So you should put that at the back of your mind. Now, that is to say, silver chloride is insoluble. Mercury chloride is insoluble. You see now, gold chloride is insoluble. Now, when it comes to lead chloride, now listen up. This lead chloride, ladies and gentlemen, boys and girls, this lead chloride have something. This lead chloride is doing what this other idiot, this guy here, is doing. And what's that? This guy is what? Is soluble. Listen up. Is soluble in warm water, but insoluble in cold water. Now, let me go back to these guys. Let me trash option C first because it's connected with these. All tetrals will be 6 salts. All of them. All tetrals will be 6 salts. Listen up. First off, let me take it like this. Ammonium salts, any salt that contains ammonia, that contains sodium, those salts are what? Are soluble. So look at it. Salt that contains potassium, that contains ammonium. Let me use that rule to trash this question. And salts that contain sodium are what? Are soluble. Now, I've done video on salt solubility before in this my lecture series. You just try and of course move and go and check the video. Now, I said that this guy is soluble. Why? It contains ammonia. Small shortcut. So salts that contains ammonia, potassium, and sodium are soluble. So automatically this is soluble. This guy is soluble. This is what? Is soluble. But this guy is not what? Soluble, except in what? In warm water. So if I heat this guy, it might be soluble in warm water, but in cold water is insoluble. So our answer there is what? Is B, obviously. Now, this is the third question that we're analyzing, but I want to bring out something very quickly. There's what we call solubility product constants. Now, they will ask us in the exam, or they can ask you in the exam. They can say, which of the following salts do not have a solubility product constant value? For a salt to have a solubility product constant value, the salt must be either insoluble or might be what? Might be partially soluble. Now listen up. And salts that are partially soluble are said to be what? Are said to be sparingly soluble. So you get the picture now. Now, look at it. So they can decide to bring out some options of salt. That's why if you are learning, you have to be very careful. Your knowledge has to be very vast. So regardless of any question you're using to do your revision, you have to be very careful to look at the option. It might not be exactly the same question, but you can use that question, of course, to get your memory back, and of course, get to put yourself in the right frame of mind to answer the main question. Now, I want to go through this again. Like I said, for a salt to have a solubility product constant, the salt must either be insoluble or what? Partially soluble. That is to say, silver chloride, yeah, can have a solubility product constant value, but sodium chloride is soluble. Obviously, we said all chlorides are soluble, and this one is not an exception. That means, of course, you can also use that. Of course, we said any salt that contains sodium is also soluble. So sodium chloride cannot have a what? A solubility product value. Why? Because it's a soluble salt. So you have gotten that. Now, the first question that we took, remember, don't forget that question. And the second question, of course, don't forget it also. That has to do with what? Gossage process, the Sabatier process, the Russell process. And of course, this is under salt solubility. Now, I see I have other questions that I want to dish out for you to know some areas in. All right, now look at another question. More target another question. Now, see this question. They said, which of the following decreases as steam changes to water? They said, which of the following decreases as steam changes to water? Now, let's analyze the question. First of all, you know that steam, vapor, gas, if it's changing to water, that means this gas is changing to liquid. Let's say that. Now, as steam changes to water, remember the vibration, the molecules vibrating reduces, and the vibration, that means the vibration of the molecule reduces, that means the collision reduces. So the steam is being converted to water. Now, remember something, that we have what? Entropy. And entropy is the what? Is the degree of disorderliness, or you can say degree of randomness. Now, this video is getting too long. I will try and cut it. Now, degree of disorderliness, or what? Or randomness of a system. Now, that is to say, let's compare between ice, water, and steam. The one that is more disordered is what? Is steam. Molecules are more disordered is steam, followed by what? Water, and then what? Ice. That means the one that has the highest entropy value is steam. That means to say, if I'm converting steam to water, what is happening there? There's a change in entropy, and the change in entropy is that it's reducing. So between water and steam, the one that is more disordered is steam. So it's changing from what? Steam to water. That means the entropy value is what? Is reducing, is decreasing. So they say, which of the following decreases as the steam as steam changes to what? To water. So obviously the answer there is what? Is C. Remember, what is activation energy? Activation energy is the energy barrier of a system. Now, this question is kind of linked to what? This number 5 question we are revising today. Now they said for reaction to be spontaneous, delta G must be what? First off, for a reaction to be spontaneous, what must happen? Now let me break everything down. Firstly, now if delta G is equals to 0, that means the reaction is at equilibrium. That means both the rate of the forward and backward reaction is occurring at the same time. So not confuse them at all. Now if delta G is negative, it means the reaction will occur spontaneously without adding any catalyst or anything. The reaction will occur spontaneously. Now, but if delta G is positive, the reaction can still occur, but it's not directly feasible. That means it will not occur on its own. That means it needs an external factor, maybe a catalyst. Now, so for a reaction to occur spontaneously, delta G must be what? Negative. Now, I'm making mention of catalyst just now. Please, I want to pay attention. I want to pay attention on something. Now, we have activation energy and we have Gibbs. Delta G is Gibbs free energy available to perform work. This one is energy that must be overcome. That's why I call it the energy barrier. Now, for a catalyst to affect a system, it affects the activation energy. So since it's a barrier, if I want to speed up a reaction, catalyst tends to do what? Reduce the activation energy. That means lowers the energy barrier, so the reaction can occur very fast. But if you want to slow down the reaction, I need to increase the activation energy. So that is how catalyst actually affects a chemical reaction. So by affecting the what? Activation energy. So please do well to know the difference between activation energy and what? And Gibbs free energy. So automatically, for a reaction to be spontaneous, delta G must be what? Must be negative. And if delta G is 0, that means the reaction is at equilibrium. If delta G is positive, the reaction is what? Non-spontaneous, or you can say non-feasible. Now, ladies and gentlemen, boys and girls, I've used like about 22 minutes to analyze some questions, about 5 questions. Of course, this is the 5th question for today. Now for chemistry, please do well to watch other videos. If you have not been following my channel, do well to watch other videos and get good information about some questions, definitely. So please, those of us that are writing post me, I wish you good success, and of course be very smart again, that the questions can be tricky, but if you put your mind to it and look at the option and read the question step by step and analyze the options, you're able to do what? To get your answer. So the exam is very technical, but you need to be very careful. Very, very careful. So that's how we took our time. So of course, you can go back to the beginning of the video and watch those questions that we have analyzed again. So please, the name is MOSJARO. Do well to share the video. And of course, the biology segment is coming up. And of course, I want to upload 1 or 2 biology questions, of course, to keep you abreast with some areas that you need to follow up. So the name remains what? MOSJARO. Do well to like and of course share the video. Thank you for watching.